Welcome after the coffee break. We are starting the first session after the coffee break today with hacking modern desktop apps with XSS and remote code execution. We are looking forward to the talk.
Awesome, thank you. So I'll wait. Okay, cool. So yeah, this talk is also a free workshop. So all the applications that I'm going to demonstrate, you can try them on their own. So if you go to 7secure.com/free, this is all available for free. And also, there's like a little bit more relaxed workshop where we kind of cover like the same contents, but in 1 hour and a half. So if you think I'm speaking very fast, just saying there's a longer version there. And yeah, thank you very much for coming, and let's see what this is about, right? So first, I'll start giving you some introduction, and then in case you have never seen an Electron application or you don't know what this is about, I'll give you some quick tips where, without having any idea, you will already have like some low-hanging fruits that you can start from. Then we will see what XSS means in the context of a desktop application. And then we will also see how to turn XSS into code execution. And then we will see two other code execution interesting scenarios that are specific to Electron, such as attacking preload scripts, and then remote code execution by exploiting vulnerabilities in IPC or inter-process communication. So I'm Abraham Aranguren. I'm the CEO of 7security. We do pen tests, we do training. We have 3 courses, each of which has a free workshop. So there's a practical mobile app attacks by example. It's a 4-hour free workshop that we have on the website. Then there's another free workshop for the web course. And then there's this, which is also like a free workshop in there for about desktop app security, but is focused on Electron security, right? We have delivered training at Black Hat, Hacking the Boss, OWASP Global AppSec, LastCon, 44Con, Hackfest, NullCon, SecT, DeepSec. I was doing the DeepSec training for the Hacking the Desktop Apps course. I've done stuff for Cure 53 and version 1. So since we are in Austria, maybe some of you are familiar with Cure 53, which is a company in Berlin. I wrote a course for eLearn Security a while back called Practical Web Defense. I don't make any money out of that, but just for reference. They were bought by somebody else afterwards, so I don't know too much about how that works now. I'm the founder and one of the project leaders for OWASP OWTF. This is an OWASP flagship project, so if you're interested about web security, this is all completely free and open source, so you just type owtf.org. See if this works. Yeah, owtf.org in your browser, and that will take you to the OWASP page for the project, and that's my slide here. And the certifications is a little bit funny, but basically I was a developer first, and then I switched to security. So if you're a developer or you're a pen tester, I got your back. I understand your point of view, so let's keep it at that. And so an easy way to learn about security can be to read public pen test reports. So I recommend, if you want to learn about security, that you do this regardless of the company that does this. But in the website, you can see from the public pen test reports, this got a little bit more media attention. So the first half of the slide is about Smart Sheriff. So we gave a presentation in DeepSec about this, I think 2016. So this was an application mandated in the entire country of South Korea. So by law, every parent and child was forced to install this application. This is the good Korea, right? Not the communist one. And the idea was to help parents be parents, so the parent would control during what time of the day the child can use the phone, what applications they can have installed, what websites they can visit. So in theory, a nice idea to help parents be parents. In practice, horrible security implementation. You could do a lot of things, like, for example, you could send an API request, and then knowing a child phone number, you would get the parent phone number and the password, and with that you would have access to the admin panel, and you could control everything about the child. So we call this the bully API, because it was perfect for bully kids, to mess with other children in the class. So if you search for Smart Sheriff Dam idea, they'll take you on YouTube for the presentation about this. And then the Chinese police and Chinese government apps, they're more kind of privacy related. So BXAQ is an application that the Chinese police install in your phone when you cross the border to a region of China called Xinjiang, when there's a Muslim minority. So it's kind of their way to keep terrorism in check in a country where there's no privacy laws, right? So they are not doing anything illegal because they control their own laws. But by European standards, it's a little bit intrusive, of course. So BXAQ, they install it on your phone, they grab the contacts, they check all the SMS messages, what applications you have installed, and they upload all this information to a police server. Then our job is more for the police officer to kind of enter like the height, the blood type, license plate, power usage, stuff like this. And then study degradation is an interesting concept, kind of similar to Smart Sheriff, but instead of mandating it by law, you get points, right? So the more that you know about the great leader of China, the more points you get, and then with these points you can do cool stuff in China, right? So this is kind of the idea. So the idea was here to help human rights activists to determine whether the stuff that the Chinese are doing with this and the kind of information they're gathering, if it was a human rights violation or not. So we were just helping them on the technical side. And if you search for Chinese police and cloud pets, I gave a talk about this. You can see it on YouTube as well. There's other pentest reports. Also, full props to these three people. File descriptor, I'm not sure if he still is the #1 ranked bug bounty hunter for Twitter, or he has been for many years. Insert scripts is Alex Infio. He's done a lot of cool research for PDF and stuff like this. He also lives in Vienna. And then Masato, of course, is kind of the king of XSS, if you're not familiar. So I recommend you follow all of them on Twitter, and they all help me, helped us to make this all better. So. This is when we talk about the course, so I'm just going to skip through this because we don't have much time. And I'll just talk a bit about what we are going to talk about today, right? So we will give an introduction about Electron, and today we will focus on the basics of XSS exploitation in Electron, exploiting node integration, some XSS and code execution mitigation essentials. And then we will also see how to find vulnerabilities in dependencies and stuff like this. Then from here, we will see a little bit about getting code execution without warnings in Windows and attacking preload scripts. Then I'm going to skip through this. This is like what we cover in the course, because sometimes we use this for the course, but I'm just going to skip it because we don't have much time. Instrumentation is interesting. It's about modifying the application at runtime, but we are not going to see this today. And today, yeah, we will see about getting code execution with XSS using file URLs. And we will also see getting code execution with IPCs, right? So there's like a few interesting scenarios, and we will see some of this today. And also, this is also interesting, right? Because we call this hacking modern desktop applications. So these are desktop applications written in JavaScript, but we have found websites that are running some Electron component. So now suddenly all these like hacking techniques that are useful to attack desktop applications can also be useful to attack a website, right? So, so we have like some interesting exercises about this. And the students were like hammering their heads about getting the code execution in this, but it's actually possible, right? So you can do a lot of stuff like SSRF, reading local files and other stuff, but also turning this into code execution by using the techniques, some of the techniques that I'm going to show today, and this is about privilege escalation and other stuff. So, okay. So hacking modern desktop applications with XSS and code execution. So let's give a quick overview about Electron, how it works, what it is, and so on. So first of all, why run a JavaScript application on the desktop, right? Just why, right? Maybe some of you are wondering about this, like, isn't this like too risky, too crazy? Why do this, right? So there's a, capitalist kind of strong reason for this, right? Because normally, if you do web application development, you have to pay Windows developers, Linux developers, Mac developers. So this is like 3 development departments. This is a lot more people to pay, and this is more expensive, right? With Electron apps, these are apps that are written in JavaScript, so you only pay JavaScript developers, and now the application magically works on everything, right? It works on Windows, it works on Linux, and it works on Mac, so this is interesting. And now the question that you might be wondering about is, who is actually using this, right? So this is just a few. Maybe some sound familiar. Right, so you have Microsoft Teams, Skype, Zoom, Slack, Discord. Right, so there are quite a few well-known players that are using this, right? So this is kind of quite relevant. So to understand how to attack Electron applications, we need to see a little bit of the basics, right? So let's pretend you click on the Discord application. So this is going to start the main process. And then for each window that the application shows, we are going to have a renderer process. So the main thing to remember here, renderer process more exposed to the user. It is the place where normally you're going to get XSS. And then, but at the same time, it can be like more protected, right, with security settings and stuff. But the main process you cannot really lock down because this is the place that has the application source code. So you cannot say you cannot run Node.js stuff here because you actually need it for the application to work. So this is like more privileged. If you get a vulnerability here, that is normally game over. If you get a vulnerability here, you can kind of contain it a bit more. So we are going to see how this works. So you have a Windows, Mac, or Linux application. So this, at the end, this is going to be talking to the kernel. And then there's going to be like some interaction between the Electron core of the application and some APIs, like interacting with the operating system. And then inside of the application itself, we have these two processes, right? So the main process, the renderer process, they can talk to each other through IPC messages, which is a fancy way of saying just sending JSON to each other, right? So they just sending messages to each other with JSON. Inter-process communication is just a fancy way of saying this. And then they can both interact with Electron by sending API calls as well, right? So we will see some examples of this today. So the main thing to keep in mind, main process, access to a lot more stuff. Render process, less privileged, can do less things. And then both share some modules that they can both call, right? So let's say you have no idea about Electron. Where do how to get started? How to get like some results without, knowing zero about this, right? So one thing that you can do is to download an application. So in this case, this is the standard Nodes application, a very old version. So you can just wget this, and then you extract it, and then you run the npm audit command. Now, the npm audit command is actually a very useful command that will not only work against Electron apps, but it will also work against Node.js in the mobile space, like Apache Cordova, Ionic, all these JavaScript frameworks. Any application, as long as it has been written in JavaScript, you can use npm audit, and this is a very useful command to run. So the first time you run it, you might encounter an error message like this, but the error message tells you what to do, right? So the reason for this is that you can sometimes have a dependency that has a dependency that has a dependency. So first, this command is going to resolve the tree of dependencies, and it's going to create a package log only file. So you just run the command in the error message, and then you run npm audit, and you get some results, right? So these are the results, and you can see, what modules that the application is running, what is out of date, and so on. Now, this is a very important topic because nowadays there's a tendency that developers, like smart developers, reuse code, right? So the applications are getting smaller and smaller, but the code that you inherit from dependencies is getting bigger and bigger. So now a big component of security is, are you keeping all these underlying packages and software up to date or not, right? Because if you are not keeping it up to date, sometimes you can inherit vulnerabilities that then opportunistic attackers can take advantage of, right? So even a perfectly secure application could become vulnerable down the line because of this. And then we can also have vulnerabilities in configuration, right? So for this exercise, we will use the vulnerable one application. So this is available in this link. And then the first thing to look at is the package.json file, right? So you open this, and then you look for the main entry point, which will point us to main.js. And then when we look at main.js, we are paying attention to this new browser window, right? So I told you before, each renderer process is a new window in the application. So this is new browser window means this is a new renderer process, and these are the security, well, the settings, and some of the settings are security related, right? So in this case, we have the location of a preload script that we will be attacking later. And then we have two security settings. which are both insecure, right? So node integration is set to true, which is bad, and context isolation is set to false, which is also bad. And I'm going to explain why now, right? So node integration is enabled, which is bad, right? So node integration true, bad. Why? Because this increases the impact of any XSS issue to, instead of just being alert 1, to immediately code execution, right? So instead of having a harmless alert, you have code execution immediately. Now, if the application has node integration true but doesn't have any XSS, you're still OK. However, if you have just one XSS in the application, this means code execution, right? So it's not necessarily a vulnerability because you need an XSS as well, but it dramatically increases the impact of an XSS issue. Then context isolation is also bad. This will make more sense when I do the demo. But basically, this means that the JavaScript code in the renderer process is running in the same context as the preload script. So this is going to allow us to mess with the definition of JavaScript functions and then bypass security controls and so on. This will make more sense in a second when I do the demo. So does anybody see a problem here, right? This is a messaging application. It takes a message from the user, and then it displays it like that. Anybody sees a problem with that? Any takers? Inner HTML, yes. So inner HTML is a DOM XSS sync. So if you assign user input to a DOM XSS sync, you have a DOM XSS vulnerability, right? So we have a vulnerability here. I think I have another slide. Yeah, so this is kind of the vulnerability here. And now maybe some of you are wondering, where do I find a comprehensive list with all the DOM XSS syncs, right? So you can Google for DOM XSS wiki. It hasn't been updated in a few years, but it's still quite relevant. And it also has XSS syncs for jQuery and other popular JavaScript libraries, so it's actually quite useful. If you're planning to use like some regular expression to look for stuff like this, it can be helpful. And then another tool that you can run is electronegativity, right? This is a tool by doyensec, so you can do npm install at doyensec/electronegativity, and then very important, -g to install this globally in your system, and then you will be able to run it as a tool. So you can do electronegativity -i of vulnerable one, which is the vulnerable application that I'm going to demonstrate now. And this will show you the vulnerability. So it tells you the file where the problem is, the lines in which the problem is, and then it gives you a link like with more information, what the problem is, how to mitigate it, and so on, right? So if you have no idea about Electron security, just running electronegativity will give you a great starting point about possible weaknesses in the application, right? So that's kind of the initial basics. So let's just do a quick demo about this. So I'm just going to run here npm audit, right? And then you see some results, right, about vulnerable stuff, vulnerable components that the application is running, and so on. Then, let me see if I find my mouse. Or maybe it'll be easier if I look here. Then we have the main file to look at in an Electron application is the package.json, right? So I'm opening this. Then you search for the main entry point, right? So I'm using VI, so I just typed here /main, right? And this takes me to the main line, which is this. And this is telling us the main.js is the main JavaScript file. So now we can go to main.js. And in here, we can observe, like, this is the new browser window. These are the web preferences. Node integration is set to true. Context isolation is set to false, both of which are bad. And this is the renderer vulnerability, right? So this would be vulnerable, which is the state right now. And this could be a potential way to fix it, right? So I'll elaborate more about this later. So one potential way to fix it is just to avoid the DOM XSS sync and instead use a safe alternative. And then I'll just demonstrate electronegativity, and now we will get, in the next demo, about talking about code execution and other cooler things. But this is just to give you a quick starting point, right? So this is the output of electronegativity. You get a lot of issues in this app because it's reenacting some vulnerabilities found in real pen tests, right? And you can see like a bunch of issues and so on. So this is an excellent starting point, right? If you have no idea, you don't know how to get started, and so on. So now, let's move on to what XSS means in the context of a desktop application and how to turn XSS into code execution in modern applications written in JavaScript. So for this exercise, we will keep using the vulnerable one application. So when you download it, and then you extract the zip file. Before you npm start, you need to npm install. This will install all the dependencies of the application. So for example, it will install Electron Node.js, which is kind of, they are the core dependencies of every Electron app. And then after that, you can do npm start. So this will start the application, and then a quick trick for you. When you use an Electron application, you can use these keystroke combinations. So you can use Control-Shift-I, or if you use a Mac, it will be Command-Shift-I. And this will open the developer tools the same way as when you press F12 in your browser. And this is very helpful to figure out why some XSS is not working, and debugging issues like this, so it makes things much easier. And then, if you have a web security background, you might try some payloads like this, right? So script alert 1, SVG, all-load alert 1. But when you try these payloads against this application, you will notice you don't get any alert, right? The code is clearly vulnerable. If you do test script alert 1 meow, you see test meow, you don't see the script, so that is encouraging. If you see this, you also see there's no output encoding anywhere in the development tool, so this is clearly vulnerable, but you don't get any alert. Right? This is according to the RFC, because the vulnerabilities at XSS, the page has already been rendered. So according to the RFC, if you inject a script afterwards, after the page has already been rendered, then the script should not execute. Right? So, but we can get around this with an image. Right? So we can do image source X on our alert 1, and this will fire. Right? So we have the vulnerability here. You can see the broken image, and you can see the alert 1. So now it's time to get a little bit more serious and start getting code execution from here, right? So I told you that node integration is bad, right? Node integration means that all the Node.js modules are available from the DOM, right? So we can load any Node.js module. There's Node.js modules that allow you to interact with the file system. There's other Node.js modules that allow you to run commands. So in this case, we're just using child process. So you can require any Node.js module you want. And then we are just executing the calculator, for example, in Windows. Or in Linux, you can execute genome calculator, ID, ls, you name, and so on. Right? And you can copy and paste from this link as well, these payloads. So this is basically what is going to happen. You can try an XSS payload like this. So the idea would be you send this to another user, and then the other user, when they are XSSed, they will run in their system all the commands that you send, right? So that is kind of the idea. So how to mitigate this? In case we have any developers in the room, or in case we have any competent pen testers willing to provide meaningful mitigation to their clients, right? So you should. Whoops. Sorry. So you should first, you should view security always as layers, right? So let's start adding layers and see how it works, how things will like, how the vulnerabilities will be like diminishing as we add layers. And then this will also help you understand how all this works, right? So the first thing to do would be to change node integration to false. So this means that the XSS will no longer be able to be automatically code execution. So if you do that, you will notice that you get this error message in the developer tools, like require is not defined, right? So this happens because node integration has been disabled, so we can no longer load and run stuff from Node.js modules. So we still have a problem, we still have an XSS, but at least the XSS is not code execution anymore directly, right? So that's good. Now, the next thing to do could be to add CSP, right? So by adding the content security policy, we can make exploitation of XSS issues a little bit harder. So If you do script source X on alert 1, we still get the alert 1, so this means we still have an XSS problem in the application. We haven't fixed this yet. So now we can add some content security policy like this, for example, default ourselves, and when we try this, if you need to close the app, open it again, and then you will notice that in the developer tools, you will get this error message. Refuse to execute inline event handler because it violates the following content security policy directive, script source self, blah, blah, right? So this is good. This is another layer of security, but we still have XSS, right? So how to fix the actual XSS? One option would be to avoid the XSS sync, right? So avoid inner HTML. So instead of having the message assigned to inner HTML, you could assign it to text content, and this will mitigate the XSS immediately. And when you try the payload again, you will notice it's rendered as text, and in the developer tools, this will all be output encoded, right? So, but then the question might come to your mind like, what happens is if I actually need to allow some HTML? Then you can consider some library that has been hammered for many years, like, for example, Don't Purify. And you can add it like this, right? So you go to the directory where the vulnerable one application is. You can do npm install Don't Purify. This will add it as a dependency. And then in the code, you can just add it here. And then you still use the DOM XSS sync, but you do dompurify.sanitize message. And this will sanitize the message before it's assigned into any HTML, right? Now, this is like useful, and it will mitigate XSS, but there's an even better way to use dompurify, which is to pass a parameter where you specify a whitelist of the only tags that you want to allow. So for example, if you only want to allow italics, bold, underline, then you would put that as a whitelist, and that will ensure that an attacker can only use those tags in addition to the sanitization. So it will be kind of the strongest defense, where you still allow some HTML, but you're not wide open to XSS, right? So when you do npm start of this, after you close the app, do npm start again, and then you can try some payloads like this. You will notice that the actual XSS is removed by the library, and then you are no longer vulnerable, right? So let's do a quick demo about this. So this would be the vulnerable one application. And I'm just going to make this bigger. Can you see this? Yeah, I think so, right? It's readable. And then in here, I'm just going to try the Linux payloads. So we'll just try them all at once. So I'm just sending a message to myself. Now, because this one is taking a little bit longer, it's the genome calculator. I'm not sure, but it takes like a second or two. So this is this. Now, since the genome calculator executed first and it doesn't return any output, in the alert we get a blank alert, right? So this is why we're getting a blank alert there. Now, this is the output of the ID command. So we can run like any commands you want. You can also have, for example, here, you could have like semicolon and other commands afterwards as well. So this is the output of the ID command. This is the output of the ls command. So we basically, this is what happens when you have node integration enabled. You can run any commands you want with XSS, right? So let's move on, because we still have other interesting things to talk about. So now we will see another interesting scenario about attacking preload scripts, right? So for this, we will use the vulnerable2 application. And before I forget, I'm going to start another VM, because we are going to do this one on Windows. So let's leave that booting. So we will use the vulnerable2 application for this. And what does context isolation mean, right? So if context isolation is set to false, which is still the default on Electron applications, you can, for example, define window.abc equals 1 to 3 on the preload script. And then if you have an XSS on the HTML, as we saw before, if you do alert window ABC, you will get the 1, 2, 3, right? So this means the JavaScript context of these two locations is the same. And this is bad, right? So this is what we are going to be attacking. And we'll see why in a second. Now, if context isolation is true, which provides better security, but is not the default yet in Electron applications, Then, if you do the same thing, you define here window ABC and it's 1, 2, 3, but then you try to do alert window ABC on indirect HTML, you will see that this is undefined, right? This is because the JavaScript here is running in a different context than the JavaScript here. And this is good because then there's a lot of attacks that you can no longer execute. So, for example, if you have a security check on the application that requires the index of function, using XSS, you can redefine the index of function. So in this case, there's a security check. It's checking that the index of function returns different than -1. And if it does, then it will open a link using shell open external, right? So which is an Electron-specific sync, right? So if you can provide a file URL, you can get code execution here, right? So you can redefine the index of function in JavaScript to always return lit. And then when this link is clicked, this will bypass the security check, and then you get in code execution. This will make more sense. We will break this down now in the demo. But basically, in the preload script, there's a safe protocols array defined. So this is the safe protocols array, and it defines HTTP and HTTPS protocols to be safe, which they are safe. And then here we have an event handler for clicks. So if there's a click and the node is an A, so href, right? So any HTML link. And then there's going to be a check here using the index of function for the link protocol. And if the link protocol is HTTP or HTTPS, which is considered safe, then this will return different than -1. So it will return 0 for HTTP or 1 for HTTPS, because this is position 0 of the array, this is position 1. And if it is anything else, it will return -1, so it will not enter here, right? So when the protocol is considered to be safe, then it will be open in shell open external. So this will basically hand over the link from the Electron application to Windows, and then Windows will decide what to do with this link. So if you can send a file URL with a Java extension, this will result in code execution without warnings in Windows, right? So this is one of the tricks that we explain in the course, and you can see it in action here. So if you send somebody a link, someday a message like this, hey, look at this, and this is the file URL, the application itself will linkify it, which is a very common feature. And then when the user clicks on this, then they will get this link is unsafe, right? Because it is unsafe. And then you just have OK, but it will not execute, right? However, if in here we send a message like, hey, look at this, and then we have here an XSS that does image source X on error, array prototype index of, and then we redefine the index of function to always return lit, then this will always bypass this, because lit is always going to be different than -1. So all links, regardless of their safety, are going to be opened with shell open external, and this is going to give us code execution in Windows, right? So if you send a message with the XSS and you click on this, then we will get a Java dialog proving that we have code execution without warnings in Windows. And this, on the developer tools, I'll show like how the logic of this is. So I think this will make more sense in the demo. So let me see if this, let me see, switch. OK, so this is what I wanted to happen in the background while I was talking about it, but just a few seconds. So yeah, I'll demonstrate now this in practice, and I think it will make more sense. I think we're doing good on time. Can you read the text, or should I make it bigger? Yeah, good. Or bigger? OK, let me make it a bit bigger then. Zoom in. Better? Yes? OK, so, whoops. This is the vulnerable application. I'm just going to close it here. And this was when the attack is successful. So I'm just going to start it again. So I'm doing npm start. And then I'm just going to make this a bit bigger. OK, I think this should be big enough. And what else? And here, I'm going to open Notepad++. Yes. So in here, we can send a message first, right, to see the security feature. So hey, look at this, right, and we send the link. So I'm just sending the link. You can see the link. There's no XSS or anything here, but when I click on it, there's this validation, right? So this link is unsafe. How does this work, right? How does this check work? So let's see. If I go here to the preload script, we can see that there's these safe protocols, right? So what I can do is I can do the same as the application is doing. So I'm just going to grab the safe protocols here, and then we are going to simulate the logic of the application, right? So we define the array of safe protocols, and now we are going to do the index of HTTP. You can see it's 0 because it's the position 0 of the array, right? So things in computers like to start with 0. HTTPS is going to be position 1, but now if I put here a file URL, now this is going to be, okay. Let me see in case this is the US keyboard or something. So you can see that this is equal to -1, right? So this is why this is working. However, since there is no context isolation, we can use XSS to redefine the index of function, which will result in any time the index of function is called, it's always going to return lead, which will always be different than -1. So when we click on this, we will be able to gain code execution directly, right? So let's see that in action. So I take this, and I'm going to try, right? So the only difference is now we are redefining the index of function. So if I send this message, you can see here the broken image. And now, okay, wait. This was an unintended drag and drop. So now you can see if I do this index of file, it's lit. If I do index of HTTPS, it's lit. If I do index of HTTP, it's lit, right? So this is the problem when there's this lack of context isolation. So now if I go ahead and click this, this is going to be like code execution. We have completely bypassed the security check because of this lack of context isolation. In the course itself, we go into other tricks, like, for example, you can redefine other JavaScript functions so that you can set an IPC to Electron itself. So that is normally the fastest way to gain code execution. But in this case, we're attacking the preload script specifically, right? So just to demonstrate this. So let me minimize this, and then we will continue now with the last scenario, which is going to be code execution through IPCs, right? So inter-process communication, fancy way of saying messaging, and in this case, we will use the vulnerable 3 application, right? So in this case, you need 2 things, right? So the main process needs to be listening for some message. So this is how this could be done in Electron. In this case, this is looking for an update event, right? So it has a listener for an update event, and then the renderer process needs to stupidly expose this functionality to send IPCs to Electron to the DOM, right? So in this case, you can see window Electron send is defined on the preload script, and then from an XSS, we will be able to call this. And even if we don't have node integration, because this is just a wrapper over this Electron function, we will be able to call this even if node integration is disabled, right? So we can basically do this. We can do Electron send, get update, and then just provide some link to get the update from. And this will make the application download this update, give it executable permissions, and run it. It is, of course, a fake update, and it will give us a Linux reverse shell. Right, so that is basically what this next demo is going to be about. And the other possibilities could be that the application defines another wrapper like Electron Open in browser, and then this is doing shell open external. And as you saw before, this means you can provide a file URL with from a network location like attacker.com and a Java extension. And this will also result in code execution without warnings. Other possibilities could be Electron listen, Electron send, and so on, right? So developers are creative for these things. And these are some possibilities. So yeah, since we're a little bit short on time, I'll just cut to the chase and just jump to the demo. But basically, we have this get update event, and when it is called, the will download event will trigger. Now, this is the JavaScript way of doing things. There's always event-based and so on, and asynchronous and stuff. So the will download event is triggered. Eventually, this will be saved in the download directory. It will be given executable permissions. It will be run. And then that's it. And then after it is executed, you will get the code execution. And this is basically the exploitation. We just send a user this link, which will be opened inside of an Electron window, and from there it's going to be game over. This is the reverse shell. It's just a typical Linux reverse shell one-liner. So from a terminal, we need to run netcat, and then when the user clicks on the link, we will get, so it will look something like this. So the user clicks on the link, then this will be received as another user. Now, since this is an example application, we send links to ourselves. And then just to start the application, in the terminal, you will see something like this, like a get update request has been received. This is the download path, download successful, running update. And then we get the reverse shell, and we can run the commands and so on. So let's just do the demo. And then we will have a little bit of time for questions. So for this exercise, we will use the, let me see, the vulnerable 3 application. So this is the application. And let me clean this up. And then what we need to do is to have here some netcat listener. And this is basically the code in this link, right? So this is it's just an HTML page that the Electron application is going to open inside of itself, right? And so I just put this message. It will be something, you have to entice the user. So, hey, look at this, or something like that. Look at this. And then you send a message. Right, the application linkifies the link, and then let me just double check if I already started netcat. I did, so hopefully, if I click on this, I get this window, and here, no, okay, this is the problem with live demos sometimes. Okay, let me try this again. So. Okay, so yes. So hopefully now it will work. Let's see. So I send a message, I click on this, and in here you can see connection received. So this is when you get excited, right? And then you can type here ID, cat etc password, and so on, right? uname-a, whatever, right? So ID. So you can run like any commands you want, and we have code execution, right? And the reason is in the source code. If we go to the main, you can see there's a get update. Let me use this maybe. There's a get update event on the main process that is looking for the update, and then this triggers the get upload and everything else I explained. And here on the terminal, you can see what's going on, right? So this is the debugging of the application. So you get the get update of a URL that is basically the reverse shell. It's downloaded into the downloads directory, and then it's just getting the shell, and it gives it executable permissions and runs it. So it runs the update, which is a fake update, which gives us the code execution with the reverse shell. So with that, we have a bit of time for questions, I believe. And yeah, this is all these applications I've demonstrated. They're all available for free there, and there's also other free workshops that we have in there. If you're interested, there's a mobile workshop, a web workshop, and then there's the Electron apps workshop, all in there for free. So 7secure.com/free. So any questions?
Thank you. Questions?
Thanks for the talk, first of all. I imagine that there are some side effects when you disable node integration and enable context isolation, because if there weren't, I mean, there would be no reason to include these features if there's no use for them.
Yeah.
So can you disable this on any application without breaking it?
As always, it depends on how the application is written. But since 2009, node integration is now turned off by default, so at least that part is good. But yeah, context isolation is still the default that it is disabled. So all these attacks about attacking preload scripts or sending an IPC to Electron and stuff like this still works by default on all applications. But yeah, the idea would be to turn both off and make the application somehow work well with both features using the secure settings. Yeah, there's always going to be, of course, it's useful to be able to call Node.js modules from the DOM. Of course, you're going to be able to do more stuff, but at the same time, if you have an XSS issue, you know, it's like Spider-Man, right? With great power comes great responsibility. So you have more power because you have the ability to run Node.js modules, but if you have an XSS, you have code execution. So it's a difficult balance, right? But yeah, it is possible. It is possible to have both secure settings, set to the right things. It's just the application needs to be written in a way that it will still work, right?
Yeah, also thank you for the talk. I'm new to these technologies, but it was very clear to me. My question is more related to your personal experience auditing these kind of applications. So of course, today you gave an introduction, and I'm sure also the big players do not commit these mistakes, but do you find often, okay, maybe I was a bit too optimistic. Do you find very often these kind of misconfigurations that can lead to effectively breaking the application, or is it like you have to build something on top of this probably?
Yeah, nowadays the node integration is just all down to the defaults. It's the same with PHP, .NET, or any other platform in web security as well. But in the case of Electron applications, it's all down to the default. So now, since node integration is disabled by default, we see this a lot less, like direct code execution through Node.js integration. But this context isolation, since it is still the default that there's no isolation, we still see this in all the latest applications. The ones that I showed at the beginning, the big players using this is still the default. Most of them are still not using the isolation and so on. Probably because since it is not the default, the developers have gotten used to this isolation not being in place, and this somehow makes development easier or something. But this is actually quite common still. Attacking preload scripts, sending IPCs to Electron to gain code execution, these are all very valid attack vectors that work against pretty much the latest application. So yeah, it's still kind of largely applicable, let's say.
We've time for one more question, if there is one.
Do you think there will be an alternative for Node.js? I mean, it's like everywhere and it's broken as fuck. And I mean, there's like Flutter for Android apps, but do you think there will be something different that's better than this? Or is there maybe already some working on it?
Well, what I have seen sometimes is that people use an Electron application, but that it is also used in React. So in React, you have to have an XSS, you have to use dangerously set inner HTML, which in the mind of the developer kind of might trigger some, thinking twice about this a bit. So I think this is the proper way, right? When writing secure code is easier and shorter and less work than writing insecure code, right? So typing dangerously set inner HTML is more work, it's longer, it's ugly. So this is kind of the right way, right? I was talking about this with somebody else yesterday, and it's like in a PHP application, right? With PHP, you can do anything you want, but the insecure code is usually the shortest, most simple and everything. And then when you want to fix SQL injection, then you have to add prepare statements, whatever. And what you had one beautiful single line of code that was completely vulnerable to SQL injection, but was one line. Now this is like 5 lines because of prepare statements, whatever. And this is the problem, right? When secure code takes longer, more effort, it's not by default that all the secure stuff is there. And then this is when you have problems. But when people use React, for example, we see the potential for XSS is that dramatically reduced, you know. And usually, one of the last things that you have is this trick about sending the file URL with the Java extension from a network location to gain code execution without warnings in Windows. So if you can find some spot where the application is going to open URLs, this can still work when everything else is being done properly. But other than that, it's much more difficult. So there's hope.
Thank you.
Thank you.